Welcome. In this tutorial, we are going to look at how to create a first-person player character with motion or control that's typically called mouse look. And what that means is that wherever I aim the mouse or wherever I aim the direction my player is facing is the direction that I'm going to go. And it also gives me the freedom to use my mouse, or, if I was using a gamepad or something, one of my axes, one of my thumb direction pads or thumb pads could be used to strafe and go forward and backward, and the other could be used to look around. Now, with this means that whatever direction I face, and if I push the W, I go in that direction, and as I move around, I do the opposite, and it still allows me to strafe left and right. This is like pretty much every first-person shooter mechanic in the world. Now, we will end up taking what we make in this, and I'm going to go ahead and jump as well. We have jumping in here, and this is all done with rigid body objects. We're going to be taking this, and we will make the next set of tutorials will actually look at how to shoot, how to use raycast or something else to potentially hit a target at a distance. Okay, so with no further ado, let's go ahead and get started. So the first thing you'll notice is that I created a terrain, and so that's something that's reasonably simple to do. All you need to do is create a 3D object called terrain. If you've never done this before, it's pretty fun. And then you can just go click on the paintbrush, and you can actually paint the texture on the surface. You'll note that I only hit a little bit of my full terrain, mainly because I just wanted a little bit of terrain here in the corner. So I've created that, and something else I just want you to note, it starts it off at 0, 0, 0 in the far corner. And so I just scooted it over a little bit in the X and the Z so that my player wasn't just floating in space when I did this. Okay. So I've got that. Now let's look at the player, and then we'll look at some of the flow graph, and then we'll go through making it. So the player actually has the camera, the main camera, as a child of itself, right? And so we're doing this in the simplest way possible right now, and we're using collision detection to check to see if we are on the ground or not. There are other ways to do this. You can use something called sphere cast, or I think it's circle cast in 2D, or maybe they call it sphere cast 2D, I can't remember. But basically you can use colliders to essentially be measuring to see how far you are off the ground, and if you're less than a certain distance away from the ground, then you are grounded. Right? In this case, we're just saying we're going to be using on collision stay and on collision exit, and we'll talk about those in just a second. Right? And so with the camera as our child, we can look at this. Now, one thing I don't have implemented currently, but we will implement in the tutorial, is the ability to look up and down with the mouse. Right now it's just horizontal, and that's because that's the first mechanic that we want to get working. If you try and put both horizontal and vertical in at the same time, because of the way it works, if you don't know what you're doing, suddenly your character is like upside down and inside out, and it just gets crazy. So let's look at this flow graph for a bit so we can just talk about some of the things we're doing and some of the conventions that we're using to make this happen. So we're doing this in several steps. So the first step is we are going to basically be grabbing all of our inputs, and this may not be the most efficient way to do this, but we're going to be grabbing all of our inputs and storing them in different variables. Now, the reason that we're doing that is because then we don't have to have flow and other wires coming down between all of these different sections of the graph. So, if I have my input get axis here and input get axis here, and I've saved them as horizontal and vertical here, any place that I want to use those again, I just bring in the variables, right? And so, this section does not have to be connected to this section at all anymore. right? So the first thing we're going to do after we get those in there is we're going to calculate our speed, right? So we're going to do the steps that we've done previously, where we're going to use the horizontal axis to figure out how fast and in what direction we're going to be moving in the x direction in the world, and the vertical will give us the z direction, right? So forward and backward, right? Side to side, forward and backward. But these are all things that we've done previously. It's just like I tried to clean it up a little bit more. And then we will, we're going to be doing a ground check, and we're going to delete this rogue unit over here, but we're going to be doing a ground check as well. And so we'll talk about, you know, how we're doing this and the kind of the system that we're using to do it. But basically, right, there's on collision stay event that we're going to be checking, and there's going to be the on collision exit event that we will also be checking. Right? If we're staying, that means we're on the ground, and if we're exiting it, that means we are jumping and leaving the ground. Right? And the reason we're checking to see if we're grounded is because we don't, in this case, let's say we don't want to be able to do multiple jumps. We want somebody to be able to jump, fall back down to the ground, and then they need to actually be able to push off the ground in order to jump again, right? This isn't a game where you can fly. We also, one of the things we're going to need to do is figure out how to rotate the player using the x-axis of the mouse. And then this huge graph over here that's way outside of its bounds at this point is updating the object velocity. Now, previously, we used different methods that would allow us to go straight forward, straight backward, and side to side. And when we were doing kind of the top-down third person of that sphere rolling around, it was pretty simple, and it worked really well in that case. However, right, you weren't able to look in a certain direction and aim in that direction. Doing that takes a little bit more work and a little bit more math to figure out. And so we'll go through some of those steps. And the idea with this is that by the end of this, you have a functional way of moving your character around the world that you can hopefully reuse if you're planning to work with this in the future. And maybe we'll all learn something about vectors and how things move and rotations and transforms and all sorts of fun stuff in the midst. Okay, so let's go ahead and get started. Okay, so our first step is going to be to create a new scene. I'm going to say new scene. I'm going to go ahead and create a terrain very quickly. Right, to create the terrain, I go, to create the terrain, I go to the plus sign, I go to terrain, it appears. And to modify it, I'm just going to zoom out. If I double click on it, if I double click on it in the hierarchy, there we go. It'll zoom me over there. I can just grab this brush and I'm just going to brush some terrain on here. And so it doesn't really matter what I do, but right, I've got a few mountains on there. Fantastic. Okay, so I'm going to go ahead and zoom in a bit on this and rotate my view a bit. Okay, so we've got some terrain, great. So now, right, with this, when this is first person, the camera are the person's eyes. And so we're going to need a container for the camera because it's just easier to have the camera's controls separate from this main object. And the main reason for that is, right, we want the camera and the figure, the player, to turn left to right at the same time. And there's a point if we were doing something in VR, we might not even want that to happen. But in our case, we want the view to change with the mouse moving left and right across the screen. We also want the view to change when it goes up and down, but we don't want to rotate our entire object in in that dimension. And one simple way to do that is to create two scripts. One that's going to be the vertical rotation is going to be on the camera. The horizontal rotation is going to be on our player object, which we're about to create. So I'm going to go ahead and say 3D. Actually, I'm going to create an empty, and I'm going to call this player. Not player game object, but just player. And I am going to go ahead and make my camera a child of the player. And then I'm going to select the player. Now, the other nice thing about this is I have this empty object that's the player. We're not going to put a model in there or anything, but you could have your camera, and then you could also have, right, a 3D model of whatever your player looks like that's also attached to this and has scripts and is running and doing all of those things. But the key element here is this empty object. So let's go ahead and add some components. We're going to need, because we're doing this with the physics engine, we're going to need a capsule collider. And the other component we're definitely going to need is a rigid body. And then we're going to need a flow graph as well, so we might as well go ahead and create that too. Okay, so I've got my capsule collider, I've got my rigid body, and I've got my camera. So I'm going to double click on my player, and you can see when I zoom in, there's absolutely nothing there. And you'll note that the player is below the terrain, I believe. So let's go ahead and fix that before things get out of hand. So my terrain is in the right place. If I select my player, it is way out of whack. So let's go ahead and just reset that completely. And then I'm going to go with my camera, and I'm also going to reset my camera. Okay, so now my camera, my player, and everything are right here in the very corner of my terrain. And you can see from this view that, I'm not seeing a whole lot of anything right now. So the first step is with my camera. I want my player to start with. I'm going to select my player. I want my player to be at 1 as my position. And I want to make the capsule collider's height 2. Right? So that means the capsule collider starts at the ground and it stands 2 units high. If you're thinking about this in terms of meters, 2 meters is like a really tall human. And so we'll leave it there. But then if I select my camera, I want you to note that even though it's still at 0, right, it's raised up 1 unit, and that's because the player is up 1, right? Now, if I want this to be closer to the head, then what I need to do is I just need to select my camera and set it to 1 in the Y direction as well. And then it'll be, really right at the top of the head. I could probably say, oh, actually it should be 1.75 or wherever eyes should be on a body. It doesn't really matter. Oh, that's not the right number. 1.75 is what I want. And if I go ahead and click on player, you can see I actually made some sort of mistake there. Let's make this 0.75 is probably what I actually wanted that to be. So let's go ahead and, there we go, perfect. All right, so we've got our player with these different tags on here. And so let's go ahead and get started with our situation. So first, I'm going to move my terrain so it's actually underneath my character. So I'm going to say, I don't know if it's negative or positive. Let's just, so I'm going to say negative something in this direction and negative something in this direction. Perfect. Okay, so now when I hit play and my character starts running, right, it doesn't fall through the ground, right? It's landing and staying on top of the surface. Okay, so pause that. So let's go ahead and start creating our flow machine. So we're going to use a macro and we're going to create a new flow graph. And I'm going to go ahead and place this in my scripts folder. And I'm going to call this, I could call it first person controller, something like that would be great. Hit save. Okay, so I'm not going to need the start event right now, so I'm going to go ahead and get rid of that. And let's go ahead and start getting some of our basic motion down and some of our some of the variables that we're going to need, right? So we've done this several times previously. We know we're going to need to get some inputs. So let's go ahead and start there. So the first thing I'm going to want to probably check is my input, and I can say .get axis. And I spelled input wrong, so of course nothing is coming up. Okay, so let's say get axis, and I'm actually going to need several of these because I'm going to need the horizontal and vertical, right, which are mapped to, horizontals mapped to the A and D keys, or the left and right arrows. Verticals mapped to the WS keys, or the up and down arrows. And then I also need some other axes we haven't talked about previously. So I'm going to go ahead and say, let's just go ahead and do horizontal for this one. And we're going to create some variables here, but we're just going to chain these all together to start with. But I think we actually have to create the variables to do that. But I'm going to go ahead and just create some more of these units, and then we'll stitch them together with the flow. So I'm going to go ahead and copy and paste this. This next one I'm going to want is vertical. Okay, so that's going to be doing my forward and backward movement and my strafing, or side-to-side movement. Now I need to be able to control my rotation, so I can look left and right and actually change my orientation eventually. And so that's going to be another input.getAxis. So I'm just going to copy and paste this. But what the name of that one is mouse X. And it's not, I'm going to go ahead and zoom in here for a bit because I want to make sure everybody sees this. It's capital mouse, oops, space X. Okay, and so how do I, oops, I have done something terribly wrong. Here we go. There we are. All right, so how do I know that name is the correct name? The way that I find that name is I go up to File, or sorry, I go to Edit, I go to Project Settings, and I select Input Manager. And granted, this is not using the new input system, it's using the previous input system. You'll note that there are, under all my list of axes, which, right, may be flipped, hidden away, but under all this list, mouse X and mouse Y are two of the axes that are listed. And you'll note that, yeah, so they, you know, those are two of my options. So I'm going to go ahead and use those. I don't know what else I was going to say. Okay, so let's go ahead and we're going to create some variables to house these values in, right? So in this case, this little top of the flow graph is just going to be checking everything and saving the values that it finds. And so we're going to go ahead and we'll make these. I think these should be graph variables. That should be fine. So I'm just going to name them the same names as the axes. So I'm going to make horizontal. I'm going to make this a float, and I'm going to leave it set to 0. I'm going to make vertical. I'm going to make this a float as well. And then I am going to make mouse. And this one, I'm not going to leave a space in there. I'm not sure if it would be happy with me or not. So I'm just going to say mouse X with no space. And I'm going to do a float as well. And so with each of these, now, right, I don't want to get these variables. I just learned something the other day that's really exciting. I don't want to get these variables. I want to set these variables. So if I have my flow graph selected and I come over here and I hold down Option or Alt and click and drag, rather than bringing in a get variable, it brings in a set variable. And so then I can come down here and you see, right, I'm going to need this flow. So I can just set this one up, and I'm just going to keep scooting on down the line here. So let's go ahead, and then we'll do, from here, we'll feed this into vertical. And then I can hold down Option and pull down, oops, if I select this correctly, I can hold down Option and drag this in here and attach my flow and attach my value and leave this here. And then zoom out just a touch, just so I can stretch this out and connect U to U. And then go ahead and hold down Option and pull in mouse X. and make this connection. Now there's one other thing we are going to be doing, so we might as well just add it now. And the last value, we're going to want to have jump on here as well. And so we're going to need to save that input. So let's go ahead and I'm just going to create jump as a graph variable as well. And I'm going to make this a bool, right? It needs to be a true or false value because it's going to be grabbing a button. And so, so then when I come down here, I'm just going to hold down Option, pull this in. And then I need to create one more input unit. So I'm going to say add unit, input, and then it's .get bu would get it down, and it's get button down. And then under button name, I'm going to type in jump with a capital J. And again, this word, which we've talked about before, is mapped to the space key, space bar. And we could also map it to other things. Oops, missed. There we go. And then now I just need to pull this over and connect these two. Okay, so these are all of the axes that I'm going to be working with. I'm saving them as graph variables because we don't need them anywhere else in the scene, really. This is just internal to the motion of our character. However, you know, if we ever need to modify these, we could go through and do so. All right, so now I'm just going to hold down Command. I'm going to click and drag, or Control if you're in Windows, and I'm just going to call this get input values. All right, so we're just going to be getting our input values up here. You can color it to make it pretty, whatever you want to do. Okay, so here we go. So we can get our input values. What's the next step that we need to do? So now we need to start doing some of the other things that we've done previously, but we're going to do them a little bit more cleanly. So the next step in this process is to start calculating the speed at which we want our character to go and do all of that, the work that we've done previously where we, check, how much time, the change in time, and we do a couple little multiplication units to make it all work out. And so let's go ahead and get started with that, and we'll start with the horizontal axis. And so I'm going to go ahead and I'm going to start with these, with this first one. I'm just going to copy and paste my update event. I'm going to double click here so I have more space and I can zoom in and you can actually see what I'm doing. So I've got my update event, and I'm actually going to be using this variable. So fortunately, they're all also over here, so I can hold down, or I don't actually need to hold down anything. I just need to click and drag to pull this in here. Right, so I need to get whatever my horizontal variable is holding. And if you remember, it's holding a value between -1 and 1. And then that's going to make my my object move really slowly unless I do some things to it. So first, I'm going to go ahead and create some object variables, right? Because I want these to be able to show up on my object and be editable while I'm in the editor and not have to go all the way into my graph to do it. So I'm going to create speed. Is my first option. And I'm going to make this a float. And to start with, we'll keep it something slow so that we, don't fly off the landscape or anything on accident. So I've got speed. I'm going to pull this in here, right? Because we're going to need to multiply our horizontal input by speed. And we're also going to need to multiply this by time delta time. So let's go ahead and create that. Okay, so these are the variables that we will definitely need. And so let's go ahead and get started with our multiplication unit. So I'm going to go ahead and click on this. I'm going to type in MULT to get multiply, and I'm going to use generic because I just know that how this is going to work. And I'm going to go ahead and copy and paste that multiply unit and put the output in here and connect time delta time. And organize this as however you want. Just, try and make it clean so that you know what's going on. So at this point, absolutely nothing is happening, right? But we're getting closer. So what we need to do is we need to have all of this basically feed into another variable that's going to hold this the speed per frame or whatever. And I don't know what we want to call it. I'm just going to call it HSPD, right? So horizontal speed, right? And again, I have this in the object variable. This would probably be better as a graph variable because this isn't something we need to access frequently. So I have HSPD. I'm going to make this a float as well. And I'm going to I'm going to click in my graph. I'm going to hold down Option, click and drag to pull this in because, right, I want to set this variable. And I'm going to go ahead and feed this in here and then just pull my update event all the way over here and connect it here. And that should make this section of the graph live. Now, I could separate this out and do the exact same thing for my for the other side, right? I could also create a super unit for this because I'm going to do exactly the same steps except with the vertical axis. And the mouse X is going to be a little different because the multiplier will be different. But again, right, it's all the same steps. Now, I'm going to leave these all exposed and not put them in super units just so all the steps are here and they all make sense. So what I'm going to do now is I'm going to select all of this. I'm going to copy it. I'm going to paste it. Now, one of the issues with copying and pasting is forgetting to change a value. So I want to make sure that this is vertical. Speed should remain the same. And then over here, I don't have a new variable that's going to fit this. So I'm going to go ahead and create VSPD in my graph variables, and I'm going to add that, and I'm going to make it a float. And now I can come over here and I can just switch to VSPD, and I can come back through here and double check and make sure everything's the same, right? Okay, so I've got this, right, speed that's being modified by time, and so it's being, amplified by the speed variable, and then being modified to be perfect frame by frame by time delta time. So I've got those two things set. And so this is going to be my horizontal and vertical motion, and this is the base. So let's go ahead and command, click and drag, base XZ motion. Now, in the past, this would have been all we did, and then we feed this in to the velocity of our rigid body, right? That would be the next step. And so let's go ahead and do that, and then we'll see the tweaks that we're going to have to make. Okay, so we've got our base motion in the XZ setup. And so what we need to do now is we're going to go ahead and just sort of recreate what we did previously, which is to just get that velocity changing on the object, right? So we've done all the math. If I zoom in a touch here, so we've done all the math to take, right, the input from our axes and our speed value, multiply those together, and then multiply them by time delta time. So we get this horizontal speed and vertical speed. So let's go ahead and we're going to start by just having these set as we normally would, and then we're going to change them. So in this next group of things, what we need to do is we need to apply these to set the velocity of our rigid body. So that is pretty simple. Okay, so let's get this graph going. So the first things we're definitely going to need is we're going to need to get our h speed and v speed variables. So let's go ahead and grab those from over here and pull them into our graph. And you'll note that with these previous two things, I've been using update events to do all of this, because it doesn't matter necessarily when these things happen, but what we want to have, what we're going to want is we're going to want to use a fixed update for this, because we are going to be modifying something in the physics engine, mainly the rigid body of our player, with the code that we create down here. So we've got our horizontal speed, we've got our vertical speed. And so what we need to do is we want to be able to feed this right into a vector 3 that we can then apply to the velocity of our rigid body. So I'm going to go ahead and create a new vector 3, x, y, z. Right? And at this point, we're not going to do anything with y. So I'm going to drop x in here. I'm going to do, vertical in the z, which vertical is forward, back, horizontal is left, right, and left, right in the x. And then I'm going to go ahead and right click and say rigid body vel, velocity, and we're going to say set. And then we can go ahead and connect the output of this new vector to the input of my rigid body. And then I need a fixed update. So if I type in fixed update should be the third option down there. I'm going to grab that and I'm going to connect this over here. Now note that I should have flow going through this vector 3, but thanks to other people, other people's graphs that I looked at online, looking for other solutions and things, I found that as long as you have flow into at least your final object, right, it's going to be dynamically pulling from this. Now, there are certain units that will give you an error if you try and do this, but for the vast majority, you can connect it like this, and it really reduces the amount of routing that you have to do. Okay, so I've got my fixed update, and it should be setting my velocity. So let's go ahead and see if this works as it stands right now. So I'm going to hit play. And if I didn't do anything wrong, there should be some things happening here. So if I press WD, you can see that I can tip and I can go forward, but then I kind of get stuck on the ground, and maybe I can roll. Oh yeah, now, right, I can roll. So what's going on here, right? It's working. I'm able to move, but this is probably not how we want our player to move around the world, unless we're creating, like a stop drop and roll game, or maybe it's like a lifeline simulator, help, I've fallen and I can't get up. So let's go ahead and pause this. So what's happening? The issue is that this is a rigid body and it's a rounded object. Somehow it's magically perfectly balanced on its end when it's at rest, but as soon as it starts moving, right, the mass of this thing allows it to fall over to whatever side, and we don't want that to happen. So how do we fix that? If we have our player selected and we go to the rigid body component, this may be hidden by default, but there's this constraints option here. If I flip this open, you'll see that I have freeze position and freeze rotation. Now, there's two directions of rotation that I definitely want to freeze to start with. And right, so if I have my player selected and I click on the rotate tool, right, we'll see, right, you can see the different colored circles, right? So if I'm rotating this direction, right, that's blue, so that's my Z rotation. So I know I don't want to fall over on my side, so let's freeze that. And then the other one is, right, I don't want to fall over on my face or back, so red is X, so I want to freeze the X rotation. For the time being, I'm going to leave Y unchecked. However, I'm just going to tell you now, we're going to want to check it later, and you'll see as soon as we hit, it'll work fine on flat ground, but as soon as we hit any sort of terrain, it's going to be crazy. And we'll talk about that in a second, but I just want to make sure that we kind of know why, because you would think logically, you're going to want to be able to rotate around the, right, you're going to be able to want to rotate your orientation left to right, but you don't want to be able to tip on either of the other directions. Now, the issue is that this is doing, what these constraints do is they freeze the position and rotation based on, say, impacts due to physics, if that makes sense. So if a sphere comes rolling out of nowhere with a lot of force and slams into my player, right, I'm going to be spun around when I get hit, like a pirouette, but I'm not going to fall over on my back or on my side with this set, right? But I can, even if these are checked, I could still use graph to allow me to rotate on my sides or rotate forward or backward, right? So this is only based on other objects in the world impacting my position. And so when I go up on rough terrain, I'm going to start getting spun around because of the shape of my collider. But I want you to see that, and then we'll fix it. Okay, so let's try this again. And remember, I have the speed set really low. It's set to 20 right now. So we're going to move pretty slowly. But if so if I'm pushing forward, it works. If I push backward, it works. If I push left, it works. If I push right, it works. Fantastic. Okay, so we've got this basic motion down. If I increase my speed to say 200, which I'm just doing over here while we're still playing, and then I click back in my game window, right, I should be able to move a lot faster, and you can kind of see this a little bit better, right? So I can move, and I can go forward and backward, and I can strafe left and right. So now I need to add my rotation, my look. So I'm going to go ahead and stop. And I'm going to go ahead and just double click to open this up. Now, before I do that, because our camera is a child of our player, any rotation that our player makes is going to rotate the child object the same amount. So instead of having our camera rotating side to side in this case, we're going to have it, as though your head is is permanently fixed forward on this character. And so let's go ahead and do that. So I'm going to double click to enlarge this to make it easier to see. Right, so this is going to be my motion, and we're going to be modifying that significantly here in a little bit. But what we need to do now is our rotation. And so the first thing we're going to need is the variable that we're using to control whether we're rotating right or left, and that's going to be our mouse X variable over here. So I'm going to drag this out. And we're going to need to do some other steps. Now, we could add okay, so we've got this variable. So there's some other things that we're going to need. We're definitely going to need to have a speed that we're going to be rotating at. Now, that's a variable we have not yet created. So, and I want that to be an object variable so I can adjust it. So we could call it rotation speed. We could call it mouse sensitivity, or rotation sensitivity, or R. I'm just going to call it lowercase r speed, right? So that's rotational speed. And I am going to make this a float, and I'm going to set this value to 20 to start with. Now that I've done that, I'm going to go ahead and pull this in. So, and then I'm going to zoom 100% so you can actually see the words on these, right? So I've got my mouse, I've got my R speed, and surprisingly enough, we're probably going to want to multiply those together. So we can I can just copy this unit up here and paste it down here and multiply these two together. And then the other thing we're most likely going to want to do is also have our time delta time be part of this. So I'm just going to copy this and paste it, and copy and paste this one more time, and then feed this in here and feed this in here. And then to finish this up, what we need to do is we need to rotate our character. So let's go ahead and say add unit, and we're just going to say rotate. If I do rotate, transform rotate, and there's this transform rotate X angle, Y angle, and Z angle. This is the one we're going to want because we're just going to want to be able to feed this in. Note, there is this other option here where you can just tell it which axis and angle. That would also work well. So let's go ahead and drop, we'll do the XYZ for now. Because there may come a point where we actually want to rotate this more thoroughly. And so I'm going to go ahead, and where I want this to go, right, is I don't, even though I'm using mouse X as my variable, what I'm doing is I'm actually translating that to Y angle rotation. So all I need to do is feed this in here. I want to make sure I'm not rotating in X or Z. And then I could either use a fixed update here, or I could use an update. It doesn't really matter because it's not technically the physics engine. So I might just go ahead and grab one of these other updates, copy it and paste it, and drop it in here. Okay, so let's see if we're rotating. So I'm going to double click. I'm going to run this. And as soon as I move my mouse left and right, I should get some orientation change. Let's see what we get. Yep, so, right. And even if I get to the edge of the screen and continue to push, just like in a normal game, right, I can rotate left and right. Okay, fantastic, right? So I've got my left and right rotation down, and you can see the whole object is rotating. Now, there's one problem with this. If I go ahead and I'm going to rotate my view here in the scene window, in this grid, the reason I've left this as a grid is because it's going to make this next little bit really easy. So I'm going to try and I'm going to click back in my window. I'm going to rotate, right, so that, you know, my rotation is perpendicular to the grid and or parallel to the grid, depending on which direction you're looking, right? If I go forward, right, I'm going to move forward along the grid. If I move backward, I'm going to move backward along the grid. And if I go left or right, I'm going to be moving side to side. And my speed is set to 20 because I forgot to reset it once I had it low. So let me go ahead and just make this 200 so it's really obvious. And then I'll click back in here and do this. Okay, all right, so same thing, left, right, you know, forward and backward. Now I'm going to go ahead and rotate my view sum to like 45 degrees. And right, ideally, I'm going to be going the direction that I'm pointed. But you'll see that that's not happening. I'm still going along the grid lines, right? I have not changed the direction that my camera is pointing, or the direction of motion. And so how do I do that? Well, what we need to do is we need to take the angle that and I'm going to go ahead and click on this. We need to take the angle that we have set here and we need to adjust the force that we're applying, right? We need to adjust the direction of our velocity, right? You can imagine velocity as, right, the three values that we're feeding in is sort of like an arrow pointing in a direction in 3D space, right? We're saying, oh, well, my, you know, I have like, say, you know, I'm one unit in the X, 1 unit in the Z would put me at like a 45 degree angle between the two, right? If I pressed W, oops, if I pressed, this will work too. If I press W and D at the same time, I'm going to go at a 45 degree angle. Or similarly, if I press A and S at the same time, right, I'm going to do the same thing. And so my arrow is currently 0 in the Y, but it's, you know, 1 in the X and 1 in the Z. And so I'm aiming, you know, roughly at a 45 degree angle that way. And depending on which sets of keys I touch, right, together, I can go at 45 degrees in whatever direction I'm going. Now, in Unity, we've talked about this before, but Z is our forward direction, right? Unity by default considers whatever direction we're pointing, like if our object is pointing in positive Z, where this blue arrow is pointing this way, that is forward, right? And this red arrow, Unity calls, right, it's the X-axis, but Unity calls that right. because that arrow points to the right when your forward arrow is pointing forward. And so what we need to do is, right, we're doing this, but we're not mapping. Okay. So the issue is, right, we're rotating our object, but we're not mapping our change in direction to our vectors, right? Because there's going to be a lot of math that we're not going to have to do because Unity is going to do it for us. But there's a lot of math that'll have to happen to essentially rotate the direction of the force that we're doing to match the direction that we want to be heading, right? Because right now our force is just, it's on that grid. It's forward, backward, left, right. But we want it to be forward, backward, left, right relative to the direction that we are pointing. And so how do we do that? It's a reasonably complex set of steps. And so we're going to go ahead and do that next. And before we do that, I'm going to go ahead and look at the other graph, I think. So to help us with this conversion between two different things, Unity has a couple units, or Bolt has created a couple units, and Unity has methods in C# that do this as well, that allow us to access our forward direction and our right direction. So I'm going to go ahead and type in, so if I type in transform.forward, and what I want to do is get it, I don't want to set it. What that does is it basically says, okay, locally, what it does is it's going to transform. What we're going to be doing is basically mapping whatever direction this is actually pointing in world space, right? In local space, it's always pointing forward, but which is local to our object. But in world space, right, we might be rotated 45 degrees or 37 degrees or something like that. And so we need to be able to get our forward. We also need to be able to get the right. So let's go ahead and grab that. So transform.right get. And so when I have those two objects in there, what I need to do now is I need to figure out which one of these I need to work with on my way to set this velocity. So first, right, the forward direction is going to be most clearly mapped to my vertical speed. And so we're going to start with that one first. And then we'll deal with strafing afterwards. So let's go ahead and do that. So we've got our transform and we've got our speed. And so what we need to do is we need to take this speed, multiply it by our transform, and then feed that result into our velocity. That's the most basic form. And so what we're going to do is we're going to go ahead and create an add unit, and we are going to say multiply. And what we want to use is we want to use the generic multiplication, because that's going to allow us to multiply a vector 3, which I'm going to put in the A field just in case, because I feel like it, I don't know if it's true, but I've had issues with it previously where it doesn't like it if you do it in the opposite direction. And maybe I was doing something else terribly wrong. Right? Okay, so what this is going to do is it's going to multiply x, y, and z of this vector by my speed. Right? So it's going to do that, and the output is going to be a vector. So I should be able to disconnect this and just feed this vector straight in here. So let's see if this works. Okay, so I can rotate, and if I'm rotated at about 45 degrees and I press forward, even though I still have my speed set to 20, right, I am actually moving the direction that my camera is pointing. And if I change direction, you'll notice that I continue to move forward or backward and follow that direction. So that's really fantastic. That is really simple and works really well, right? It's not a big change, but all it's doing is it's saying, you know, whatever direction I'm pointing, put the speed in that direction. Now, doing the strafing is a little trickier, right? Because we need to be able to then say, okay, whatever direction I'm pointing, I want this side-to-side motion to be there as well. So the first step is similar. So let's go ahead and stop this. And the first step is going to be to take our transform right that we have down here. And I'm going to go ahead and double click, make this larger, and zoom this all the way in so it's easier to see. Okay. So, but what I'm going to need to do is I need to take my horizontal speed, and I'm just going to disconnect this from this new vector 3 for the time being. And what I want to do is I want to multiply these two as well. So I'm going to, again, disconnect that. I'm just going to do some house cleaning here to make this a little bit cleaner so they look very similar. So I'm going to take my multiply, I'm going to copy, I'm going to paste, I'm going to drag this down, make sure my vector 3 goes into my A, my floating point value here goes into my B. And so now we've got this done, and we've got these two vectors. But what do we need to do now? So now what we need to do is, you know, we need to combine these two. And the trick is that we want to make sure that because, and I can't, let me go ahead and we'll play this again because I want you to see what happens to these values, right? So previously, if we had a vector 3 and we were moving forward and backward, the value would only be changing in the z, right? And if we were moving side to side, the value would only be changing in the x. But because we're transforming our, right, because our direction isn't pointing, you know, straight, you know, along the axis, we're actually going to be doing motion in both vectors. But I want to show you that real quick before we go too far. And I totally forgot to do this again. And so I don't even need the screen up. So you'll see right now my transform here is set to 1. My speed is 0. If I press forward or backward, oh, I have to actually get out a full screen here and click in there. But before I do that, I'm going to go ahead and set my speed to 200 so it's a little bit more clear. Okay, so you'll see that as I rotate my view, and I don't know if you can see this, so I'm going to try and zoom in here on your, and still actually be able to manipulate this without moving the window around a lot. But you can see, right, as I rotate this, the values in that vector are changing, right? There's a little bit in x and there's a little bit in y and z, right? I'm not getting any change in the y direction because I'm not going up and down, right? I'm just changing the direction I'm looking, and so I'm getting little variations there. And so what's going to happen is if I add force to that, you can see that it's actually creating motion in the x and the z values. And so if I was just to go in here and feed this value into z like we would have done previously to do forward and backward motion, that's not going to work, right? And because what we need to do is we actually need to combine whatever's happening in x and whatever's happening in z in both this vector and in the other vector that's going to be controlling our strafing. Those need to be added together before they get fed in here so that both effects are accounted for. So I'm going to go ahead and, oops, sorry, wrong button. I'm going to go ahead and pause this. And again, right now, because I keep forgetting, I'm going to change my speed to 200 so it stays. And so what I'm going to need to do now is come down here, and I've got these two graph objects, and what I need is I need an addition. And I'm going to go ahead and I'm going to type in add, and I'm going to use the vector 3 addition because these are both going to be vector 3. So it says add in math vector 3. So you can see that vectors are what's in here, so I can go ahead and drop these both in. And then what I should be able to do is apply this here. And now I should, if everything is working, have motion in the X and Z. So let's go ahead and see what happens. I should have strafing enabled. Right, so first, if I don't move my direction at all, right, I can go left and right along the grid lines, forward and backward along the grid lines. Now, if I rotate my view some degrees, I can go forward and backward, and then I can go left and right perpendicular to my forward direction. Right, so these subtle changes allow us now to have, right, this mouse look, so we can look back and forth, and we can kind of go wherever we end up aiming. Right, and so we're doing this with mouse X and Z. You could have other keys mapped to this. And so here's one issue that I wanted to show you is if I go up here, I'm not turning my controller around. As I get up here, it's turning around on its own. And so what's going on? So this is where that freeze rotation in the Y direction comes in. Right, if I click this, it stops me from spinning. However, if I click in here, I can still use my mouse to spin my direction, right? It just means that if I'm on uneven terrain, I'm not gonna be spinning around. Or if I run into a box or some other object, it's not gonna make me pirouette across the screen. Although that might be a really funny effect to have to make your players nauseous, but it's not really what we want to do. Okay, so let's go ahead and stop this. So now, great, we have a lot of success here, right? We've got our rotation done. So I'm going to go ahead and create a group around my rotation stuff and just say rotate player. And then I've got my motion started. Now, there's a bit more that we need to do because we haven't dealt with jump yet. And so we need to make sure that we get our jump logic built into this. And so that's our next step. And then once we get jump built in, then we'll do the vertical look with our wide, basically being able to look up and down with our camera. And the reason we're waiting to do that is because the first few steps in that, your camera goes totally crazy. Okay, so we've got this set. We can get rid of this vector 3. I'm going to right click and click delete. So do we have our grounding yet? No, we don't. Perfect. Okay, so let's go ahead and start by creating our ground checks. So our ground check is going to be pretty simple. What we need to do is we basically want to know, are we on the ground? And the easiest way to know if we're on the ground is to use the on collision stay event. We don't want on collision enter because as we move across a surface, we're going to be entering and we're going to vibrate a little bit, or basically every time we move, it's going to trigger this enter. And we don't want this to be happening just all the time. We only want it to happen. We only want a change to occur when we actually jump off the surface, right? Because we want to make sure we can't jump unless we're on the ground. So the first thing we need to do is we need to select our terrain, and we need to apply a tag to it. And the tag we're going to apply is ground. So if you don't, there's another way we can do this with a layer mask, but we're not going to worry about that right now. But if you don't have a ground tag already, just click add tag, type in ground, and then select terrain again, come back here and select ground, right? Remember, if you create a new tag, I wish you could create a new tag when you have an object selected and it would automatically apply that to that object, but it doesn't. So you just have to come back and do it a second time. So ground is the tag that we want our ground to have. And then we're going to right click in our graph. We're going to say add unit, and we're going to say on collision stay. And so with our on collision stay event, I'm going to double click because we don't really need to see what we're doing in there. We just need here, right? This is our player, and it's basically saying, okay, if we're staying in a particular collider, and so I'm going to click on collider, I'm going to click over here once, and I'm going to type in compare game object compare tag. And the tag, right, I'm going to type in here just ground. All right, so I've got my game object compare tag. And then if this is true, then what we want to do is to figure out how we're going to make that control one of our variables. So right now we've got our jump, and this is meant to be like, I've hit the key and I'm trying to jump, right? That's our, we could even call it is jumping or something like that, or, jump button or jump hit or whatever. But what we need is we need to know if we can jump or not. And so we're going to create one more object variable. This could be a graph variable as well, but we might want to just, for testing, sometimes it's nice to have it out and available. So I'm going to type in can, capital J-U-M-P, can jump. I'm going to hit plus, and I'm going to make this a bool. And by default, it's going to be false, so I'm going to leave that value field unchecked. And I'm going to pull this in here. So what's nice about this is if I am, right, this graph is really, really simple. Oh, and I don't want to get the variable, I want to set this variable. So I'm going to delete this tag, and I'm actually going to hold down Option or Alt, click and drag on can jump to pull this in there. There we go. So, and in this case, I'm going to go ahead and just connect my flow through here. And what's nice about this is the value that I want is true or false. And I want to be able to, when I'm on the ground, I want to be able to jump, right? So if this is true, then I can jump. So I can just connect this directly here. I don't need to do any additional logic or checks or anything. It's a really simple graph. So then the next step to this is when I exit this collider, right, when I leave the ground, I need to make sure that I cannot jump. So I'm going to go ahead and right click and click add unit. I'm going to say on collision exit. And on this exit, I'm going to copy these two options. I'm going to say command copy, command paste. Pull these down here. And so I want this collider to go into this where it said self. And I definitely want to connect this flow through here. However, at this point, right, this on collision exit, right, when it exits, it's going to set this to true. And that's not what I want. I need to be able to set this to false. And so, I'm going to need a little bit more logic to do that. So I'm going to disconnect this. I'm going to disconnect this. I'm going to pull the, oops, I have both of those selected. I'm going to select just this one. So I am going to need a branch here, right? So I'm going to right click. I'm going to say add unit, branch, which I spelled terribly wrong. There we go, branch. Select this. I'm going to take my flow in here. So when it's true that I am exiting, that I've exited my collider, I want my flow to come in here to set this variable. And the question is, what do I want to set it to? The easiest way to set it to a false is to click on here, click over here, and just type in, and actually I don't have to type anything. My fourth option is bool literal. If for some reason that isn't showing up, just type in bool space L and you will get this. So I want a bool literal, and I'm just going to leave this box unchecked, right? Because what this is going to do is when this flow comes through here, it's going to set the value of this variable to false. So I will not be able to jump once I leave the ground. Okay, so these are my ground checks. So I'm going to go ahead and I'm just going to wrap this up as we go. So I'm going to hold down command, click and drag, and I'm just going to say ground check. Okay, so, right, so now I can check if I can jump. So now what I need to do is I've got my ground-based motion all dialed in here. But what I need to do is I need to figure out how to add my vertical motion onto this. And so the first thing we need to do is check to see if we can jump. And then, it basically, what we need to do is we need to say, okay, if I've pressed the space bar, which is the jump button, and I'm on the ground, then I can jump. So the first thing I need to do is make this possible. So I'm going to grab my can jump variable, and I'm going to also, I believe it's a graph variable. I have jump as this graph variable here, so I'm going to go ahead and drag this as well. Right, so I'm going to get these two variables. So I'm going to get whether or not I hit the jump button and if I can actually jump. And I need to do a little bit of logic here. What I need to do is I need to say, right, because I want, if I can jump and I have pressed the button, keyword being and, then I want to execute the rest of the code to do a jump. So I'm going to right click, I'm going to click add unit, and I'm going to just type in AND. And AND is a logic, right? It's just logic, and it means if both of these things are true, then do it. It's a nice little Venn diagram that shows us what it means. But so if I feed this in here, then I'm checking both of those things, and if both of those things are true, then I need to jump. And to jump, what I'm going to need to do is I'm going to need to add my jump height, which is a variable I have not created yet. I'm going to need to say, essentially, how much force am I putting into this system? And I need to put that into the Y direction. So I'm going to go ahead and come down here, and these are my graph variables. I actually want this to be an object variable. I'm going to say, let's just call it, we could call it jump force. Is probably the best name for it because it is a force and not a height. And then I'm going to say float, and I'm going to set this to 10 to start with. Once I've done that, then I'm going to go ahead and pull jump force out here. And this part's going to be very similar to this other section over here, right? What I want to do is there's another transform, right? We have forward is right in the Z direction, right is in the X direction, and in the Y direction points up. And so surprisingly enough, transform dot up tells us our vertical transform. So I'm going to go ahead and use that. And the reason I'm doing this is maybe there's a point where for some reason your character actually can rotate some and you can launch at an angle off of something rather than just jumping like straight up every single time. We're not going to program that right now, but by doing it this way, we're making it kind of future-proof for doing that without creating a whole lot of changes. So I'm going to say transform dot up and get. And then I'm going to do the same thing where I want to multiply my jump force by my up vector. So I'm going to hold and copy and paste. I'm going to drag this over here. Oh, and I think I'm making a mistake. So I'm just going to move these around a little bit. Always do this. There we go. And then, right, I've got these multiplies. I'm going to pull this, and this logic is going to go over here for just a temporary little bit, because in terms of this graph, it seems like it makes the most visual sense to have all of these things happening and be somewhat aligned to make more logical sense. So then what I'm going to need to do is I'm multiplying these together, and I want to add this to the rest of to these other two things. But I only want to add this on here when this occurs, right? So I'm going to need some sort of branching logic. And this is where, the logic, I'm going to put my logic up here. And I'm going to take my fixed update and disconnect it temporarily. And what I'm going to do is I need a branch unit, right? Because there's two options here, right? So I'm just going to type in branch, right? Either I am going to jump or not jump. So I'm going to take my fixed update, I'm going to feed it into the input of my branch. If this is false, right? If I'm not jumping for whatever reason, whether it's because I'm not pressing the jump button or because I can't jump, I just want to have this flow go straight into this rigid body here, where it's just going to do all of these, right, this section of the code. Now, if it's true, I need to do something a little different. And so what I'm going to need to do is I'm going to create a couple more add units, and I'm going to have another rigid body velocity set. So first, I'm just going to go ahead and copy and paste this and drag it down here. And then we need to do these next few steps. So let's do that. So we're going to go ahead, and we definitely know we need at least one addition. So I'm going to go ahead and copy and paste this, because I'm going to want to be adding my jump to the output of this, right? So I'm still doing all of this work, but these two are now being added together as well, right? So I'm essentially adding my V on here. I need to connect this over here, and then I just need to take my true and drop it down here. Now, you know, maybe it would have made more sense to have these sections of the graph flipped, but hopefully they're reasonably easy to follow. All right, so one last time we'll go through the logic, and then we'll test it and see how it works and see if I made any horrible mistakes. So we have a fixed update event happen, right? Flow goes in, and before it can make a decision between which one of these paths to take, it has to check if we can jump or if we want to jump. If we do not want to jump, it's going to flow right into this velocity set, which means that it's going to pull just from the forward and right motion, and it's going to feed that into our velocity. If, however, we can jump, we want to jump, and we can jump, then it's going to run down here, and it's going to set our velocity here, and it's going to do all the same steps here, but it's going to add our up vector as well. So let's see if this works. I'm going to be so excited if we can jump without any errors on the first go. And okay, so I can still rotate my view. I'm actually going to select my player in my hierarchy so you can see this in the window. So right, I can rotate and I can jump. I don't know if I have enough jump force to jump very far right now, and there may be another issue that's happening. All right, so you'll notice that I'm falling pretty slowly. We've seen this in the 2D things as well. Let's see if I make my jump force 20, if that makes much of a difference here. No, right? There's something going on. If I hold down Option and pull this down, right, you'll see that, and click, right, you'll see that I pop up there, but something weird is happening. So let's go ahead and stop this. And you might have some idea of what it is, because it's something that in previous tutorials we've had issues with as well. When I'm doing all of these steps here, there's one thing that I am not doing, and that is, right, because if we play this again, and I'm not jumping right now, and I'm all the way zoomed in, so we should be able to see the values, right? You'll note that my y velocity, oh, I guess if I press forward, here we go, right? No matter what, my y velocity is 0. Now, what that means is that even the way I'm doing this, I'm resetting that velocity to 0 as soon as I'm done pressing the jump button, right? This starts playing again, and my y velocity is set to 0, right? Which isn't what we want at all. We want this to be set to whatever. We want it to flow naturally, right? Right now it's just snapping. So I'm going to go ahead and stop this. And what I need to do is I need to essentially create one more add unit, and then I need to add very specifically just the y, the velocity in the y direction. So what I can do is I can just say add unit. And I'm going to start, I need to get my rigid body velocity. So I'm going to say rigid body dot velocity. So .vel, and I want to get it. And then I don't want to add in the existing x and z velocities, right? Those I'm setting very deliberately through here. And if I end up doing this, it's going to essentially amplify my it's going to double my speed and I'm going to start flying off the map very quickly. So we don't want to do that. We just want to get the y. So I'm just going to select this. I'm going to type here. I'm going to say get and vector 3 get y. And then what I need to do is I've just got this y value coming out. And so I need to put this into a new vector 3 that will basically have a 0 for the x and a 0 for the z while I still have this y value. So I'm going to say new vector 3 x, y, z, just feed in the y value. And then this final step, and I'm kind of running out of space here, so I'm going to double click to open this all the way up. I'm going to zoom all the way in, and I'm going to take my logic that looks so beautiful up here and move it further up so I just have a bit more space to work. So I'm taking my rigid body velocity, I'm grabbing the y value of whatever it was. Basically, we're taking our previous velocity and making sure it gets added in here. So now that I've got that, I'm going to go ahead and create one more of these addition units. I'm going to copy and paste. And I'm going to drop this in here. I'm going to pull this into here, and then I'm going to connect the output of this one over here. Right? So our graph looks really uniform in a sense, right? We've got we've got some, this is our up vector stuff going in here, and this is just our existing, whatever our previous y velocity was, we're updating it. It might be 0, it might be -1, whatever it is. We're just going to update it and feed it in here so we don't have that 0 every frame setting our y velocity back to 0. Okay, let's go ahead and try this, and then we'll clean our graph up just a little bit. Okay, look at that. Now I'm jumping like granted, if I could jump, whatever, 10 meters in the air, whatever that is, that'd be amazing. I'd break my legs if I actually fell. But so we can jump, right? We can turn left and right. We can, in this case, the code that I've written, we can actually, while we're jumping, we can still control our left and our X and Z motion. And that's really up to you in terms of gameplay, right? This is basically the same type of motion that you have in, say, Counter-Strike or something like that, right? You can jump. Granted, we don't have crouch written in, but you can jump. You can, and you can control your direction and speed while you're in the air, which is not physically accurate, but it doesn't really matter right now. Okay, so yay, we've got that working. So let's go ahead and clean this up and box it in, and then we will work on vertical, looking up and down. So I'm just going to grab these units, pull this down, right? And this looks really, really complex, but hopefully the way this is laid out, it's clear what's happening. And hopefully through the instruction I just gave while we were doing this, it's clear as well. I found a lot of tutorials out here that do this, but they don't do a whole lot of explanation as to why you're doing what you're doing. It's just in an effort to be quick, it's just put these units in. And so hopefully this explanation makes sense. All right, so this will be our, I'm just gonna say set velocity is all that we're doing there, right? All of that complexity to set our velocity.